In this video, we're going to investigate the idea of a limit. And I'm going to introduce it to you by contrasting three different functions, f of x, g of x, and h of x. And at least superficially, they look a little bit different. They've got different formulas, but we want to see the degree to which these functions are really the same or whether they're, in fact, meaningfully different. So let's study them each in turn. First up, f of x equals x plus 1. So I've given you the graph of this. It's just going to be some straight line. Wonderful. Now I want to look at, instead, g of x, which is x squared minus 1 over x minus 1. Whenever we have something like this, a polynomial on the top and a polynomial on the bottom, I want you to have an alarm bell going off in your head that says, can I factor? Can I perhaps cancel something from the top and the bottom? So indeed, if we try to factor x squared minus 1, then what we're going to get is this is the same thing on the numerator as just x minus 1 times x plus 1. And then indeed we have this x minus 1 on the bottom. Now, if you were to just cancel the x minus 1 and the x minus 1 on the top and the bottom, if you just get rid of them, what you'd be left with was x plus 1. And if you just have x plus 1, well, that indeed was precisely what we had for f of x. X plus 1 was just that. So, is this the same thing as f of x, or is it a different thing from f of x? It's almost the same in my mind, but there's a very slight difference. This function here, I can do this canceling whenever x minus 1 is not 0. Indeed, in that one case where x is equal to 1, and so the denominator x minus 1 will be 0, you have a division by 0, and this function is not defined at that point. So when I draw its graph, what I'm going to do is something like this. You see down here I have x equal to 1. That was our problem spot. That's the one spot where we've got this division by 0. At x equal to 1, the way I illustrate it on the graph is this little circle with a hole in it. And what that means is that this function is not defined at that particular point. There's just no value. G of 1 is undefined because you have this weird problem. So the graph is almost the same as the graph for f of x. It's still the same straight line, but with the difference that this is not defined at that one point, and so the domain, the allowable input values, are very slightly different. Okay, so f and g are a little different, but let's compare with h. Now, h is something called a piecewise defined function. And if you haven't seen this notation before, what it means is that you have two different possible functions that h is going to be, and I tell you when they're going to be which of those two ones. So for the exact value of 1, it's going to be 3. And what this means is that h of 1 is equal to 3. But then if I have any other value, the h is just equal to x plus 1, and x plus 1 is that same function f of x. So how does this graph work? Again, for most values except for x equal to 1, it's just the exact same thing. It's that same straight line. Except at the one special point of 1, special because it's being pulled out here, that what you have is this point, and I fill in the dot to say that's where the point is, and it's got this height of 3 coming from the 3 in my formula. So this so-called piecewise defined function, again, looks very, very similar to f of x, but a little bit different. And a little bit different from g of x as well. G of x only had the open hole, but did not have the closed-in dot. So now if I go back to my three different functions we're talking about, well, the way to analyze them is they are the same everywhere except at 1. Because f of 1 is 2, and g of 1 wasn't even defined. There just was a division by 0, it didn't work out. And then h of 1 is the value of 3. So these functions are different at the point 1, but other than that, they're going to be the same.